So here I am here to present on the topic development and standardization of chickpea enriched rasgulla. As we Indians, we are more familiar with this dessert called as rasgulla. It is a sweet that is originated in the northern part of India, which is in Bengal. Rasgulla is a sweet, mainly the main sweet which is consumed in those part of the country. So here in the study, we have decided for an alternative to reduce the sugar content as well as an alternative for the milk, commonly used cow milk. We have tried to bring an alternative for that purpose. So in the first slide, we are going to see the evolution of Indian sweets, that is in the traditional as well as the modern changes. In traditional way, in India, it meets or it is a privileged place where we use lots and lots of sweets, and the major sweet we are using is sugar. And after sugar, the major sweetener what we are using in all our food or any sweets or in any savories is jaggery. So the traditional sweets like rasgulla, sandesh, peda, all these are prepared out of milk, and the major sweetener we are using here is sugar. So that is one of the challenge what we were focusing on. And on the modern challenges, in the modern challenges or maybe after the corona period, the one of the main challenges, people have started eating more thoughtful. Okay, the major population has started consuming food in a more thoughtful way. They are into sugar to diet, calorie deficient diet they are planning. And one of the major crises what we are recently facing or in the recent years facing is type 2 diabetes for the children or for the teenagers, as well as obesity. So these are the modern challenges we were focusing on, and we were planning or we were focusing on these challenges to develop a new food product. So here the product we have used or why we have chosen pulses is due to the increased population or the increasing alarming population in the Asian countries like China and India. To meet the population and to supply food for the whole population of these two countries or the whole world, the WHO and all the country are planning or they are focusing on different sources to meet the necessity or need of these people. So on those bases, other than providing them with milk, an alternative for milk, because milk, the production of milk cannot reach the complete population. So something that is similar or some product that could be giving nutrients similar, not the exact same, but similar or which is close to milk. So that is how these pulses come into importance. Also, in the recent years, the people or the population, they are trying vegan diets or the low calorie diets, or those people nowadays, there are lots and lots of women who are facing PCOS or PCOD, and one of the major problem they are facing is lactose intolerance. So other than women, even men or even kids, in the recent years, there are many kids, men and women, that is in every age group, every sex, everyone is facing the major issue is lactose intolerance. So a substitute for milk or something that could match the nutrients of the milk, that is where we have brought out these or why we have selected pulses in our studies. And chickpea, it is a commonly used legume in almost all parts of the country and especially in the Asian countries. And the third most abundantly grown pulse or legumes. And it is, if we check the protein content, pulses typically contains 21 to 25% of protein, that is twice that found in cereals. And the starch content is 41 to 50% starch, that is the white color chickpea. In the Asian countries, there are mainly two types. One is a Kabuli chana or the Kabuli chickpea, that is the white one, and the other one is Bengal gram, or that is the brown color or the black color. So here in the Kabuli variety, we are having 41 to 50% of starch. And they are having higher concentration of soluble sugars. And if we take around per 100 gram of pulse, the protein content is around 19 grams of protein, which will help in the muscle repair and growth of the muscle. So here the pulses, they are nutritionally benefit. They are rich source of folate, iron, magnesium, phosphorus and manganese, and they have good dietary fiber which helps in digestive health. Vitamin B, as I told earlier, they have low glycemic index. So those people who are going for low calorie diets, they could focus on these pulses or especially on chickpea, as well as they are having essential amino acids such as isoleucine, lysine and tryptophans. So all these were the factors which we have focused in developing a product using chickpea. So innovation meets tradition. So here in this research or in this project, our main problem identification or one of the major problem was how can we attain something that is being traditionally followed in the whole country, or the traditional rasgulla. It is having high sugar content, that is around 50%, which is unsuitable for diabetic people or lactose intolerant issues, and concerns about saturated fats, cholesterol in dairy products, because rasgulla, it is something which is having, we are curdling the milk and preparing. So the whole fat as well as casein has been curdled. Along with casein, there is high fat content. Whatever fat is there in the milk, that is being concentrated. So this was the problem, and the solution we have thought about, or the design solution for this, was to replace the dairy chana, or to replace the milk with chickpeas. And the product development, what we have done was to create chickpea milk and curdling them and making it into a rasgulla or balls that could be cooked in sugar syrups. And the research objectives, what we have focused were formulation, how to formulate a product out of pulses or out of chickpea or a legume into something that is being already familiar to the population. And the nutrient analysis, it should almost, or most commonly, it should meet the nutrients which was there in the milk. And the sensory quality, how well its appearance, flavor, texture, taste and overall acceptability for the people. So understanding rasgulla, or how rasgulla is made out of chickpea. So this is the common rasgulla preparation process, that is milk preparation. Milk, here the preparation process is, we heat the milk, coagulate the milk with acids, then we strain the casein as well as fat, that is, and we throw out the whey protein, whey water. Then we knead it, make it into shape, and we cook it in sugar syrup. Around 40 to 60% of sugar syrup, we cook it inside it for 20 to 25 minutes. This is the basic process of rasgulla preparation. So here what we have focused, or our experimental design was to take chickpea and milk into different variations. So here we have soaked the chickpea for around 8 hours overnight soaking. Then we have grinded it and separated the milk from the chickpea, curdled the mixture to form paneer, that is to prepare the variations 1 and 2, that is which is having 50% and 40% of milk. The main focus was to prepare paneer out of it, and we have used in both these cases, the variation 1 and variation 2, we have used lime juice or vinegar, acetic acid for the curdling process, and where 100% of chickpea milk was extracted. we have used a salt that is called as Nigari salt or the magnesium chloride. In the same process, the rest of the process is same. We have washed the curdled or the chenna, we have rounded it into balls, or we have given the shape, desired shape, cooked it in syrup. It has doubled the size, and we have allowed it to stay for 1 or 2 hours to absorb the sugar inside the rasgulla. And this is a sensory evaluation, pictures for sensory evaluation, that is around 40 to 45, around 50 semi-trained panel members have analyzed the rasgulla. The standard, in the variation side, we can see the standard, that was the rasgulla that was prepared with milk, and variation 1, variation 2 and variation 3. V3 or the variation 3 is complete 200 ml milk of chickpea was used, and it was completely prepared out of only chickpea milk. And so here in the sensory evaluation, after the sensory evaluation, everyone, those who have tasted the traditional one, they have automatically opted the first one, that is the standard. And after that, there was a difference in flavor when we are mixing in 2 different variations, the cow milk as well as chickpea milk. Once we are using the complete chickpea or only chickpea, 100% chickpea milk, the taste has come almost similar to the standard. So it has given high scores for the appearance, color, flavor, texture and taste. In the nutrition profile, we are going to see it was a healthier alternative compared to the milk, as there is no fat content in chickpea, or the very low quantity of, or low or no fat content was there when we are considering the V3 or the variation third one. 64 to 64.64% carbohydrate, primary energy source. Protein was around 16.3%. Fiber, it had around 6.92% of fiber. Health benefits, what we have seen was chickpea rasgulla offers superior nutritional benefit as there is no fat content and it is having high fiber content. That was a major nutrient aspect. What we could face here was, once we are comparing it with the rasgulla prepared with milk, this chickpea incorporated rasgulla, it was having very low fat content and high fiber content. And this is a commercial viability and market potential. In few supermarkets and shops, we have placed the prepared product, that is chickpea or the vegan rasgulla, and the price given for this was, for per 100 gram, the total cost for per 100 gram of chickpea, we have given it as 95 rupees. Once it is refrigerated, that is at 4 degrees Celsius, we could keep the product to 5 to 7 days, or if it is in room temperature, 1 to 2 days. Once we are freezing it, or we are keeping it in a frozen state, 1 to 2 months we could store the product. And our target people or our target consumers were health conscious consumers, diabetic individuals, lactose intolerant, vegan or vegetarian community, fitness enthusiasts, and export opportunities. We are looking on to the export opportunities, how we can store it, or what are the methods or what are the forms where we could develop more out of it, and how can we store it. Or in all these sectors, we are working on this. So I would like to conclude. We have developed a product that was a complete vegan product, or a vegan sweet that has replaced, or which is used, or which we can use it to replace the traditional high sugar or high calorie and high fat rasgulla. And one of our future research, or what we are planning, is to develop sugar-free sugar syrup through different methods, how we can make the product even sugar-free so that it could reach many people, those who are health conscious or fitness people or diabetic people. A sugar-free alternative we are planning, that is our future research. And my team with whom I could do this project, Dr. A. Geeta, Assistant Professor, Department of Chemistry from Hindustan College of Arts and Science, Ms. Logida, Assistant Professor, Department of Food Processing, Technology and Management, and Mr. Aditya, our student, who is a final year student, Department of Food Processing from Hindustan College of Arts and Science. Thank you. So if there are